Hello, and thanks very much for the opportunity to speak today. My name is Izzi Monk. I'm Policy Advisor for the Environment at the Royal Society of Chemistry, and I lead our policy work on the circular economy of materials and also net zero. And when Steph invited me today, she asked me to talk about designing for circular economy and how that might apply to the conversation today around PFAS alternatives. So I'm going to start by talking in a little bit more of a high level way around why this is so important to be thinking about circular economy before thinking in a bit more detail about some of the design principles that I think are appropriate for the workshop today. So I'll start by talking about why we need a circular economy and how this relates back to the triple planetary crisis of climate change, biodiversity loss, and waste and pollution, as is illustrated with this diagram on the slide. Back in March 2024, it might have been February, the UN's International Resources Panel published a report which made clear that unsustainable resource use is the main driver of the triple planetary crisis. And it's highlighted the need for urgent global transformation towards a sustainable use of resources. And as this report made very clear, far from being separate from efforts to combat climate change, unsustainable material use contributes directly to greenhouse gas emissions, as well as degrading ecosystems through land use and the chemical pollution that's released, which very much reduces their ability to store carbon. And I'd say that unfortunately, progress on this front has been far slower than for UK decarbonisation, although these are really highly interlinked areas, but often talked about quite separately in the policy circle. So, at present, we operate in a linear economy where materials are extracted, made and used in products before being thrown away as waste at the end of life. And estimates suggest that the UK's population consumes 15.3 tonnes of materials per person per year, which is well above the global average. So, not only does that mean that we are contributing disproportionately to the problem of unsustainable materials use and the impacts that this has both on the environment and on health as well, but also the economic value of those materials is lost from the UK economy if they end up in landfill, if they're incinerated or they're exported abroad. And some estimates suggest that at present as little as 7.5% of materials are circulated back into the UK economy. And there's a great deal of pressure on some of these resources. So many of the materials that we use in, for example, our everyday consumer electronics are also essential for renewable energy as well. So we need to make sure that we have the right supplies of these materials. So again, circular economy here will be quite important in sort of managing that material use. One thing I just want to talk about then is kind of what the concept of a circular economy means in terms of its principles. So, in a circular economy, materials are kept circulating at the highest value for as long as possible within the tightest loops. So, on this diagram, when I say the tightest loops, I'm talking about things like reuse, repair, are much tighter loops than recycling and recovery at end of life. So a circular economy helps to minimise extraction and also minimises waste, which obviously both come with quite significant environmental and health impacts. And the circular economy needs to be enabled at material, component, and product level, and probably needs to occur at different scales as well. So it might be we're enabling a circular economy within an industrial process, or at a local or UK or a global level as well. So we need to be thinking on different scales when we're talking circular economy. One thing I do want to touch on before I talk about designing for circularity is the need to make sure we're not just thinking about recycling and consequently creating a recycling economy. And I hope that this slide here helps to illustrate that point. I think it's very easy to slip into a focus on waste and recycling, and I say that this is where a lot of the focus of the policy conversation is currently and has previously naturally fallen. But there is a lot more to a circular economy than that, and hopefully workshops like this one helps to explore moving beyond just thinking recycling and end of life. And things like the circular economy strategy announcement from government is a really welcome sign that we're trying to think a bit more broadly than just recycling. being able to talk about designing for circularity is really great, as it's a topic that keeps coming up, and we think it's a really important one to probe more deeply if we want to establish a circular economy rather than a recycling economy. So a lot of the time, the focus seems to be in these kind of discussions around design, on what I'd call the more physical design phase. So how something is constructed, which is obviously really crucial for things like disassembly for recycling and repair. But it's also really important to be thinking about a much earlier stage in the design process, which is where discussions about alternatives is going to be so key, because this goes right back to the kind of the material selection stage and why we're picking materials and their properties and so on. And obviously, with a quite a tight schedule on this talk, I want to just give a very high level overview of some of our current thinking on principles of designing for circularity, help to prompt some of the conversation later. So, very much stating the obvious, PFAS alternatives should be at least as sustainable, if not more sustainable, than what they are replacing. And we need to be looking across the life cycle when we are making that assessment. So, we're thinking about the fate of the material in the whole system. So, if we take, for example, a smartphone that I'm sure all of us have in hand, in a circular economy, it will have multiple use phases. So we'll have it using it as a product for lots of its life. It might be that we can then split it apart to use the components in the next phase, and then ultimately there might be a material phase as well. And all of those need to be enabled in a circular economy, as I alluded to earlier, and therefore we need to be making assessments of the impact of the materials it contains at each of those points as well. So the whole life cycle of these materials is going to be key. Where we can avoid using materials, particularly more hazardous ones, or considering how they can be constrained in a product, will also be really important. And alongside things where the risk or sort of what the risk involved is when the product is repaired or remanufactured as well. So not just thinking about the risk to people at end of life recovery, but also in the repair and remanufacturing stages, and what that exposes people to, and the environment to as well. So whole life cycle assessments are important if we want to avoid regrettable substitution, where the PFAS alternative is worse than what it has been designed to replace. And similarly, it's going to be really important ensuring that we're not merely burden shifting an impact from one point in the life cycle to another point, which simply is just changing the load on the system in a different way. And I'm sure we can all think of examples where there have been, and not necessarily in the PFAS environment, but examples of regrettable substitution or kind of like this burden shifting of impacts around the system. So being able to understand and evaluate the trade-offs is another very interlinked point here. So it's my third point here. There may be a need to strike a balance, for example, between longevity or the durability of a product and its recyclability or how it's managed at the end of life. And that's probably going to be very context dependent. So it may well be that assessment might need to be made on quite an individual basis on sort of like a product level or beyond. And finally, very much to link back to my first slide, I just wanted to touch on as well. But we need to be thinking about not just greenhouse gas emission impacts. We are in a triple planetary crisis, as I said at the start. So when designing for circularity, we need to be thinking about other impacts on the environment. So, for example, water, air, and soil pollution, as well as the social and health impacts as well, which are all crucial considerations when designing the alternatives. So, essentially, with those four principles for designing for circularity, we're going to need to be thinking about quite an interlinked suite of ways of enabling those better practices principles. And there's obviously a great deal more depth and complexity than can be talked about in this brief presentation here. But they're going to be things like the need to make sure that data is available to make life cycle assessments. That's going to be really crucial, and that data needs to be available. One thing we've heard feedback on is that it might be commercially sensitive or that it's expensive to access as well. So we need to be thinking about ways that data can be enabled for people. Another thing that is going to be really key, again, with something we get a lot of feedback on when we're talking to stakeholders around circular economy, is the need for interdisciplinary approaches. So again, workshops like this are really great to get those conversations going between different parts of value chain. And this very much points to the need for the whole life cycle collaboration. And like this thing of people being very siloed. So, for example, the designers may not talk to people who are working in the end of life. So, collaboration will be key. And alongside that, there will also be some policy levers which will be really crucial. So one of the things that we've long been calling for is the development and delivery of a clear overarching strategy, which is coordinated by central government to enable a circular economy of materials in the UK. So we're going to need a suite of policy interventions to enable a circular economy, and we have put forward 5 recommendations. I'm not going to talk through all of those in detail today, conscious of time, but I've highlighted the 2 which are the most relevant to the conversation, which is to make sure that we are supporting world-class research into sustainable materials, including those limiting emissions along entire material and product life cycles. And the second, which is to invest in and incentivise resource-efficient design, production and processes alongside assessments of criticality and substitutability of materials. And those 2 hopefully are really relevant for this conversation today. So I'm going to leave anything further in terms of more detailed explanation, but just to say thank you very much for the opportunity to speak today. The QR code and the website link there will take you through to our pages around circular economy of materials strategy and our policy asks, as well as some of the things we have said to government on our consultations, and very happy to also take questions. And my email address is on the slide there. So thank you very much.